We've all got this picture in our heads, right? To solve the world's biggest problems, you need this super team of specialized AI geniuses all working together. But what if that's completely wrong? What if the key isn't a team at all, but just one single brilliant mind?
It's a question that really cuts to the heart of how we're building the future of AI. The dominant idea has always been that more is better. To crack the really big challenges, we're going to need an army of AI agents collaborating. But a fascinating new research paper is asking us to seriously rethink that entire assumption. Okay, let's dive right in. The concept that's got the AI world buzzing is called multi-agent systems, or MAS for short. The idea is actually pretty simple, but really powerful. Instead of one AI trying to do everything, you create a workflow for a dream team of agents. You might have one agent as a data analyst, another as a creative writer, and a third as a super careful code reviewer, all passing the task along to get a much better result.
So here's our game plan for this explainer. We'll start with the promise of this AI dream team. Then we'll uncover a hidden detail that kind of changes everything. We're going to ask if one agent is actually enough, look at the pretty surprising results, and then see what this all means for the true frontier of AI.
So let's kick things off with the prevailing wisdom. The big promise of multi-agent systems is that by breaking down a really complex problem into smaller pieces, you can assign each piece to a specialized agent. The hope is that this leads to a way better outcome than a single AI could ever manage on its own.
And these systems aren't just some chaotic brainstorm. They're actually highly structured. Each agent gets a specific job description, that's its system prompt, and it gets its own set of tools, like a web browser or a code interpreter. They follow a very specific workflow to get the job done, and it's proven to be incredibly effective for all sorts of complex tasks. But here's where the story takes a really interesting turn. The research paper we're looking at points out a critical detail that's been mostly overlooked. When you actually look under the hood of most of these AI dream teams, you find something surprising. They're not actually a diverse team of different minds. Most of these systems are what we call homogeneous. That means every single agent in the workflow is built on the exact same base large language model, the same core AI brain, like a GPT-4 or a Claude 3.5. They're basically just clones with different job titles. A truly heterogeneous team with agents from different AI models is much, much rarer, mostly because it's just way more complicated to build. And this one little observation leads to the central, super disruptive question of the entire research paper. If everyone on the team is just a clone of the same AI, do you really need a team at all? Let me put it this way. Think of an incredible actor who can play multiple, totally distinct roles in the same movie. The actor has one brain, one set of skills, but can adopt all these different personas. So the paper asks, can a single LLM do the same thing? Can it just role-play the analyst, then the writer, then the reviewer, following the exact same workflow script, but without needing a whole cast of clones? So the researchers put this whole idea to the test across 7 different benchmarks, covering everything from coding and math to real-world planning. And the results were, to be honest, pretty stunning. And the answer was a huge, resounding yes. A single AI, just role-playing its way through the workflow, performed just as well as the entire team of clones. This pretty much proves that it's the workflow that matters, not how many AIs you throw at the problem. But get this, it gets even better. Not only did the single agent perform just as well, it did it so much more efficiently. It was faster, and it was cheaper to run. This isn't just a minor improvement, it's a fundamental shift in how we should be thinking about building these systems. So how is this possible? Well, the secret is a technical detail called the KV cache. The easiest way to think of it is as the AI's short-term memory. A single agent playing all the roles can just remember the context from one step to the next. It doesn't have to reread the entire script from the beginning every time. In contrast, that multi-agent system of clones has to reprocess a lot of that information for each new agent, which wastes an enormous amount of time and computational power. So why is this such a big deal? Well, for anyone building AI applications, it means lower costs, faster responses for your users, and more consistent results. And for the researchers, it sets a powerful new baseline. Before you build a complex team of agents, you now have to prove it can beat a single, well-instructed one. Now, building on this powerful insight, the researchers didn't just stop at the theory. They created a practical tool to put it into action, developing an algorithm to make these single-agent workflows even smarter. They call it One Flow. It's an algorithm that takes this power of one principle,
and uses it to automatically design the most streamlined workflow for a single agent to execute. It actually learns and refines the steps itself, creating a process that maximizes both performance and efficiency. A one-flow workflow might look something like this. For a complex query, the single agent first plays the analyzer to understand the context. Then it switches roles to become a detail extractor to pull out all the key information. After that, it works as a refiner, improving the answer until it's confident, before finally acting as a formatter to present the perfect output. All of this done seamlessly by just one AI. Okay, now it is absolutely crucial to understand the limits of this finding because that's where we find the next great challenge for AI. Remember, this whole one is as good as many rule only works because we're talking about those homogeneous teams, the teams of clones. It completely changes the moment you start talking about a team of truly different AIs. You just can't have one AI roleplay another model's unique way of thinking.
And this is the paper's final, crucial point. The real, unsolved frontier is figuring out how to build and coordinate heterogeneous teams, where you might have a Claude model working with a Gemini model and a Llama model. The challenge is making sure the benefit of their diverse minds is actually greater than the cost and complexity of getting them all to work together.
So that's the question this research leaves us with. It proves that a single, focused AI can be just as powerful as an army of clones. But the ultimate goal, the real prize, is still out there. Can we build a true team of diverse AI thinkers that is genuinely greater than the sum of its parts? The answer to that question is going to shape the next era of artificial intelligence.